Good evening. I'd like to talk about solve quadratic equations by completing the square. I will discuss this subject by solving some few examples. First, we need to solve the quadratic equation, which is x squared plus 10x equal to minus 9 by completing the square. First of all, there is a standard form for the quadratic equations before starting the completing the square, in which all the x terms are inside and the constant in the other side. So the equation we have here fulfill this requirement. So x squared plus 10x is equal to minus 9. On the left side, we have two terms with x variable, and the right side of the equation is the constant. First, we should identify the value of b. Here b is the coefficient of x, it is 10. Then we compute b by 2 all squared, which means we need to find the square of half b. So b over 2 squared is equal to 10 over 2 squared. 10 divided by 2 is 5. 5 squared is 25. Now we add this value, which is the 25, to both sides of the equation. So the left side becomes x squared plus 10x. This is the plus 25, we add it, is equal to minus 9, and this is the 25 on the right side. So the equation still balanced. Now we can simplify for the right side of the equation. So x squared plus 10x plus 25 is equal to 16. You can conclude that the left side of the equation can be factored because it is a complete square. So the left side of the equation, x squared plus 10x plus 5, can be factored. So we need to factor the square trinomial as a binomial square. So the binomial square for this equation is x plus 5 all squared is equal to 16. So x squared plus 10x plus 25 is a complete squared, so it can be factored by x plus 5 all squared. You can check for this by multiplying x plus 5 by itself, so you could or you should reach the x squared plus 10x plus 25. Now we use the square root property. We take the square root for the both sides of the equation. So for the left side, the root square of x plus 5 all squared is x plus 5. And for the right side, we have two solution, which is the plus minus root square of 16. And root square of 16 is simply 4. So x plus 5 is equal to plus minus 4. So we have now two equations, two linear equations. We can solve for x. So for the first equation, x plus 5 equal to plus 4. So if you add minus 5 to both sides, we get the solution for x to be minus 1. So this is the first solution for x, it is minus 1. The same way we can solve for the second equation. The second equation is x plus 5 equal to minus 4 now. So simply we can add minus 5 to both sides. So x becomes alone in the left side. So x is equal to minus 9. So we have two solutions. The first is minus 1 and the second is minus 9. So these are two solutions we have. Now we can simply check for our two solutions by substitution the x by the original quadratic equation. So let's check for the first solution, which is x equal to minus 1. So the original equation is x squared plus 10x equal to minus 9. Checking for the first solution means that if we substitute for x in the left side by minus 1, the result should be same as the right side, which is minus 9. So let's compute for x squared plus 10x and for x equal to minus 1. So x squared is minus 1 squared plus 10x, 10 multiplied by minus 1. Minus 1 squared is 1. 10 multiplied by minus 1 is minus 10. So it's minus 9. So it is same as the right side of the original equation. So we conclude that it is correct. Now we can check for the second solutions, which is x equal to minus 9. So the left side, x squared plus 10x. Now we substitute minus 9 for x. So minus 9 squared, 10x means 10 multiplied by minus 9. Minus 9 squared is 81. Plus 10 multiplied by minus 9 is minus 90. So the result is minus 9. Again, we get the same result on the right side of the main equation. So our second solution is correct. Let's understand the way of solving the quadratic equations by completing the square by taking this another example. Solve y squared equal to 5y minus 1 by completing the square. First of all, you can see that the equation is not in its standard form. So we need to isolate the y terms on the left side and the constant to be on the right side. So if we add minus 5y to both sides of the equation, we get y squared minus 5y is equal to minus 1. So this is the equation in its standard form. Now we compute for half b squared. So the value of b is minus 5. So b divided by 2 squared is minus 5 divided by 2 all squared. Minus 5 squared is 25. And the 2 squared is 4. So the square of half b is 25 over 4. Now we add this value, 25 divided by 4 to both sides of the equation. So y squared minus 5y plus 25 over 4 is equal to minus 1 plus 25 over 4. We can simplify the right side of the equation by using the least common multiple. See that the 25 over 4 is a fraction. So the denominator here is 1. So we need to find the least common multiple for both 1 and 4, which is the 4. So y squared minus 5y plus 25 over 4. The minus 1 becomes 4 over 4. and the second term becomes the same, 25 over 4. So we have two fractions with same denominator, which is 4. So minus 4 plus 25 is 21 over 4. So this is our equation. As you see here, the left side is complete square. So we can factor the square trinomial as a binomial square. So the left side becomes y minus 5 over 2 all squared. And you can check for the result to get the original equation. And the right side is 21 divided by 4. Now simply we can use the square root property. So for the left side, the square root of the left side is y minus 5 over 2. And the root square or square root of the right side is plus minus root squared of 21 over 4. So the root square of 4 is 2. So the result is plus minus root square of 21 over 2. So now we have two linear equations. The first one is y minus 5 over 2 is equal to plus root square of 21 divided by 2. We can simplify this equation. We can simply add 5 over 2 to both sides. So if we add plus 5 over 2 to both sides, we can get the first solution for y, which is 5 divided by 2 plus root square of 21 divided by 2. And the second linear equation is y minus 5 over 2 is equal to minus root square of 21 divided by 2. So simply we can add plus 5 over 2 for both sides in order to simplify. So the equation, the linear equation becomes y is equal to 5 divided by 2 minus root square of 21 divided by 2. So we have here two solutions. This is the first one, and this is the second one. So these are the two solutions we get for y. Now we can simply check for the first solution. So this is the first solution. And checking for the first solution means that if we substitute this value of y on the left side, which means if we square this value of y, and we compute the 5y minus 1, they should be same. So let's first compute for y squared for the first solution. So this is the value of y all squared. So we have two terms all squared. So the first term, we square it. So 5 divided by 2, the square is 25 divided by 4. And we square the second term, so we get 21 over 4 plus 2 times the first term times the second term. Now we can simplify, so we have 25 over 4 plus 21 over 4. This 2 cancel with this 2, so the remaining is 5 root square of 21 divided by 2. We can also simplify these values. So 25 plus 21 is 46 over 4 plus 5 root square of 21 over 2. This is an even number and this is an even number, so we can simplify it to be 23 over 2 plus 5 root square of 21 over 2. So this is the value of y squared. Now we compute for the right side of the original equation, which is 5y minus 1. We should reach the same answer here. So 5y minus 1, 5 multiplied by, this is the y, minus 1. So 5 multiplied by 5 by 2 is 25 divided by 2. And the second term is 5 root square 21 over 2 minus 1. Now we can simplify these values by taking the least common multiple. So the least common multiple for the 2 and 1 is 2. So this is the first term and this is the second term. Regarding minus 1, we multiply both the numerator and the denominator by 2. So we reach minus 2 over 2. So 25 minus 2 is 23 over 2 plus 5 root square of 21 over 2. See that we have the same solution. Regarding the second solution, I leave it to you. Now we need to solve for x plus 6 multiplied by x minus 2 is equal to 9 by completing the square. See that the left side of this quadratic equation is not in its standard form. So what to do is simply to multiply this binomial by this binomial. So we get x squared plus 4x minus 12 is equal to 9. Again, this equation is not in its standard form. We need to keep the x terms alone in the left side and the constant to be on the right side. So simply we can add plus 12 to both sides. So for the left side, x squared plus 4x minus 12, this is the plus 12 is equal to 9, and this is the plus 12. So the equation is still balanced. So now we can simplify for the two sides. So x squared plus 4x is equal to 21. Now the equation is in its standard form. So now we can follow the steps. Now we should compute for half or the square of half b. The value of b, which is the coefficient of x, is 4. So 4 divided by 2 all squared is equal to 4. Now we should add this 4 to both sides of the equation. So the left side becomes x squared plus 4x plus 4. And the right side becomes 21 plus 4, which is 25. As you see here, the left side of the equation is a complete square. So we can simply factor the left side to be x plus 2 all squared. And this is the right side is 25. Now we can use the square root property for both sides. So for the left side, the square root is x plus 2. And for the right side, the square root is plus minus root square of 25. And root square 25 is simply 5. So we have plus minus 5. Now we have two equations. We can solve for x. So if we add minus 2 for the equations in the above, So we get x is equal to minus 2 plus minus 5. Now we can find the first solution by taking the plus 5. So x is equal to minus 2 plus 5, which is equal to 3. And the second solution is x equal minus 2 minus 5, which is minus 7. So we have here two solutions, which are 3 and minus 7. I will leave the checking for you. Thanks a lot for you. That's all about solving the quadratic equation by completing the square. Thanks a lot. Goodbye.